Okay, to start us off for 11.3, we're going to start up with just a little bit of a warm-up. So here we're asked to simplify the square root of 60. Remember here we're going perfect square hunting. Which perfect square is going to 60? And if nothing comes to mind right away, remember you can always do your factor prison where you can break down 60. So I'm okay with either strategy in this case. Don't know why I have so many greens. Let's just break down 60 to show that way. If we have 60, we can break that into 2 and 30. 30 we can break into 2 and 15. 15 will break into 3 and 5. So we know the square root of 60 is just the square root of 2 times 3 times 5. Remember, 2 times 2 can get pulled out, so we just have 2. Then the inside we're left with 3 times 5, which is just 15. Then we're also asked to solve 2x minus 9 equals 7. Yes, it's just as easy as you're thinking. Add 9 to both sides. 2x equals 16. Divide by 2. X has to be 8. So in 11.3, we're combining these two ideas. We're going to solve equations that have radicals in them. So the strategy we use is very, very similar to when we're just solving for x. We're going to isolate the square root first. So we're going to try to get the square root of x or the square root of whatever we're dealing with all by itself. And then all we need to do is square both sides of the equation and then solve for x. So here for this first example, we have the square root of x minus 7 equals 0. So we're going to try to isolate that square root. So we're going to add 7 to both sides. So now we're left with the square root of x equals positive 7. So now you can think the square root of something has to be 7. Well, you might think right away, the square root of 49 is 7. How we know that is because we can square both sides. The square root of x squared is equal to 7 squared. So x has to be equal to 49. You don't need to put this step in when you're working through these, but this is the process we're doing to go from the square root of x equals 7 to x equals 49. Let's look at a little bit more involved example. We're going to isolate this whole square root, subtract 3 from both sides. So we're left with the square root of 2x minus 3 equals positive 1. Squaring both sides, we're going to have 2x minus 3. We just get what's in the radicand is equal to 1 squared, but 1 squared is still just 1. Now we still need to solve for x, so we're going to add 3. Whoops. So 2x is equal to 4. Divide by 2. X is equal to 2. What's nice about all of these is you can always go back and check your work. 2 times 2 is 4. 4 minus 3 is 1. The square root of 1 is 1. 1 plus 3 is 4. Boom, we're in business. Okay, here for example number 3, we have the square root of 2x minus 1 is equal to the square root of x plus 4. So this is different because we have 2 of these radicals. But the process we're going to use is the same. See, we have these things isolated. They're both by themselves on either side of the equal sign. And what this is saying is the square root of something is equal to the square root of something else. So what that means is that 2x minus 1 would have to be equal to x plus 4. In the same way, the square root of 3 is equal to the square root of something. Well, the only thing that the square root of 3 is going to be equal to is the square root of 3. So what we're going to do is we're going to square both sides, or just say that 2x minus 1 is equal to x plus 4. Because those radicands need to be equal. So now we just play algebra like we've normally done. Subtract x from both sides. We get x minus 1 equals 4. Add 1 to both sides. X has to be 5. Check your work. 2 times 5 is 10 minus 1, the square root of 9. That'd be 3. 5 plus 4 is 9, square root of 9 is 3. So 5 is our answer for x. Why don't you go ahead and pause the video now and try this next one on your own. Okay, so here we're going to add 6 to both sides. 3x plus 1 equals 8. Square both sides now. 3x plus 1 is equal to 64. Subtract 1 from both sides. 3x is equal to 63. Dividing by 3x has to be 21. So I'm hoping you've got 21 as your answer. If you were to plug that back in, you'd see that you do get 2 on the left. Okay, how about this one? We have 2 times the square root of 2x minus 5 equals 26. Now, it might be tempting to distribute this 2. Please, please, please do not do that. All we're saying is 2 times the square root of something is equal to 26. So if we're trying to isolate this square root, we want to divide by 2 on both sides first. That's always going to be our first step. So please don't distribute. Now we have the square root of 2x minus 5 is equal to 13. Squaring both sides, 2x minus 5 is equal to 169. Add 5 to both sides, 2x is equal to 174. Then we take 174 divided by 2, we should get 87. So here when you're multiplying a constant times a square root, please just divide it. Do it how you would normally do solving for x. Okay, one thing we need to watch out for is what are called extraneous solutions. And the idea of an extraneous solution is when we looked at the graph of the square root of x. Remember, this graph was only defined for positive values of x. So we didn't have anything over here in the negative region. So if we're looking at this problem, the square root of x plus 9 equals 0, we'd subtract 9 from both sides, have the square root of x is equal to negative 9. And then we'd square both sides, so x is equal to positive 81. This looks like a good answer, but then when we replug that back into our equation, square root of 81 is 9. 9 plus 9 is 18, but that's not 0. And the idea here is that the square root of x cannot be a negative number. You also can't have the square root of a negative value. We can't have anything over here. So we just need to be aware that the square root of any number has to be positive or 0. So let's look at a couple more examples here before we finish, working maybe with these extraneous solutions. So here we have the square root of 3x minus 17 minus the square root of x plus 21 equals 0. Now we have another situation where we have 2 different radicals, but these are not isolated right now, so we're going to add the square root of x plus 21 on both sides. So we have 3x minus 17 equals the square root of x plus 21. We're going to square both sides now, get 3x minus 17 is equal to x plus 21. Subtract x from both sides, we'll have 2x minus 17 equals 21. Add 17 to both sides. 2x is equal to 38. X is equal to 19. So not an extraneous solution here. 3 times 19 minus 17 is still greater than 0. 19 plus 21 is 40. That's still greater than 0, so we are in business. Let's look at number 6 now. We have the square root of x after we subtract 5 from both sides is equal to negative 5. Now you probably notice this is much like our last example where we have the square root of something equaling a negative. So we know right away we'll have no solution. If you don't realize that right away and you go through the process, you'll have x is equal to 25 when you square both sides, because negative 5 squared is 25. But then when you replug this back in, you have the square root of 25 plus 5 equaling 0. But 5 plus 5 is 10, and 10 does not equal 0. So that'd be why we have no solution in this case. So just be aware that you might not have a solution to all of these. So just be sure to go back and check your work. So that does wrap us up for 11.3.